Hi, Michael.
How's it going?
So I want to talk about something today, Michael. I want to talk about Bayesian learning. And I've been inspired by our last discussion on learning theory to think a little bit more about what it is exactly we're trying to do and to move beyond specific algorithms to just think more generally of the sort that learning people want us to do, learning theory people want us to do. And I think Bayesian learning is a nice place to start. Okay? Sound fair?
Yeah, that sounds really cool. I think maybe that would be a nice kind of formal framework for thinking about some of these problems.
Good, good. So I'm going to start out by making a few assertions, which I hope you will agree with. And if you agree with this, then we'll be able to kind of move forward and ask some pretty cool questions. Okay? So, Bayesian learning. So, the kind of idea here behind Bayesian learning is this sort of fundamental underlying assumption about what we're trying to do with machine learning. So, I've written it down here. Here's what I'm going to claim we're trying to do. We are trying to learn the best hypothesis that we can, given some data and some domain knowledge. Do you buy that as an assertion?
Yeah, and pretty much everything we've talked about so far has had a form kind of like that. We're searching through a hypothesis space, and as you've pointed out on multiple occasions, there's this kind of extra domain knowledge that comes into play. For example, when you pick like a similarity metric for something like k-nearest neighbors.
Right. And of course, we always have the data because we're machine learning people and we always have data. So this is what we've been trying to do. And I'm going to suggest that we can be a little bit more precise about what we mean by best. And I'm going to try to do that and see if you agree with me. Okay, so I'm going to rewrite what I've written already, except I'm replacing best with most probable. Okay, so what I'm going to claim is that what we've really been trying to do, what all these algorithms are doing, is we're trying to learn the most likely or the most probable hypothesis, given the data and whatever domain knowledge we bring to bear. You buy that?
Interesting. I'm not sure yet. I mean, so is it the hypothesis that it's most likely to be returned by the algorithm?
No, it's the hypothesis that we think is most likely given the data that we've seen, given the training set and given whatever domain knowledge we bring to bear on the problem. The best hypothesis is the one that is most likely, that is most probable or most probably the correct one.
Interesting. Well, are we going to be able to connect that to what we were talking about before, which is generally we were selecting hypotheses based on things like their error?
Yes, exactly. We are going to be able to connect that. We are definitely going to be able to connect that. But
Okay.
I can't go forward unless I can convince you that it's reasonable to at least start out thinking about best being the same thing as most probable.
Yeah, I'm willing to go forward with this. It sounds interesting.
So if you're willing to move forward with this, then I want to write one more thing down and then we can sort of dive into it. So if you buy that we're trying to learn the most probable hypothesis, the most likely one, the one that has the highest chance of being correct given the data and our domain knowledge, then we can write that down in math speak pretty simply. It's the probability of some particular hypothesis H drawn from some hypothesis class given some amount of data, which I'm just going to refer to as D from now on. Okay? And that's just exactly what we said just above when we talk about the most probable H given the data. Okay?
Well, wait, two things. One is, so D is not distribution, which we've had in the past. So I
That's
guess
true.
as long as we keep that straight. And the other one is, no, you're just telling me the probability of some particular hypothesis H.
That's right. So we want to somehow, given this quantity, we want to find the best or the most likely of those hypotheses given this. Does that make sense?
Yes.
So we want to find the argmax of H drawn from your hypothesis class. That is, we want to find the hypothesis drawn from the hypothesis class that has the highest probability given the data.
Perfect.
Okay, good. So we're going to spend the next 45 hours exploring this expression.
Okay, so that's like what? It's like 6 hours per letter.
Yeah, and that's fine because it's important.